Hello, everyone. Welcome to another episode of the Aunty Pharmacist podcast. How was your weekend? I hope you enjoyed it as much as I did. It's Monday again already, and I want to say welcome to a new week. I hope that this day sets a good tone for your whole week. Now that I've got all the great things out of the way, I will be talking to you today about something very important. Actually, I'm surprised I haven't had it as a topic on this podcast because it is something very dear to me. Although I've mentioned it time and time again while discussing other topics. So that counts too, right? Well, it's Antimicrobial Awareness Week. So I guess I was waiting till now. I'll be discussing antimicrobial resistance, otherwise known as AMR. It is such a menace now that even WHO calls it the silent pandemic. Why this scary name, you might wonder? I'll be doing justice to it and letting you know what you should do to avoid it on today's episode. Listen to this.
So you're telling me the strongest antibacterial the CDC has won't work?
Doesn't even make a dent.
Well, then we need to think of something else, and fast. Our supplies are pushed to the brink. I mean, the ward you just put me in charge of is almost full.
Okay, what about something other than antibiotics, like phage therapy?
I've already tried it. Nothing in the phage trials works on this strain.
Immunotherapeutics like pegfilgrastim?
Or heavy doses of probiotics for microbiota modulation?
They're good as preventative measures, but it's too late to help those already infected. I have tested every drug modeled, every outcome, and all these roads lead to the same place. I'm sorry, Max, but there's no antibiotics on the market that can fight this infection.
That was a scene from an episode of one of my favorite medical dramas, New Amsterdam. Watching this scene a while back, resonated with me. It gave a clear picture of the menace that antimicrobial resistance may cause. And I'm sure that you've heard it yourself, how this superbug in that hospital in this drama caused a lot of confusion. They could not find any antibiotics that could help the patients, and the death toll was rising. So we do not want this. This is like the worst case scenario. And why am I doing this episode today? It is to create this awareness. I've seen test results of patients' antimicrobial culture sensitivity in which the microorganism is resistant to every known antibiotic. How do we then help that patient? Which is why I'm doing this episode today, to create awareness about antimicrobial resistance. And like I said, it is Antimicrobial Awareness Week from now till Sunday. So you have to be antimicrobial resistance aware, which is why I'm doing this episode. Without further ado, let's get right into it. By definition, antimicrobial resistance is the phenomenon whereby microorganisms, that is the bacteria, virus, fungi, parasites, develop the ability to thrive even in the presence of substances that should have killed them or inhibited their growth. It is such a scary thing because the ability of your healthcare providers to treat you and help you to fight various infections is due to the fact that there are substances, medications that can either kill or stop the growth of the infection-causing organisms in your body. Now, imagine a situation whereby there is no way to control these organisms. That is a disaster, Did you know that we are surrounded by microorganisms? They are present everywhere, from the air we breathe in to our environment and even water bodies, even on our skin and inside our guts. Of course, we have protective elements like our skin, which serves as barrier to their entry, nasal air and mucus that help to trap them and prevent us from breathing them in, as well as our immune system that helps us to fight them, even if they get into our bodies, as long as they do not overwhelm the immune system anyway. However, there are times when these causal organisms overpopulate the body and even the immune system cannot fight them. Then they manifest as infections. This is when we need to deploy antimicrobials depending on the causative organism. Antibacterials, otherwise called antibiotics for infection due to bacteria, antivirals for infections caused by viruses, antifungals for infections caused by fungi, antiprotozoals and anti-helminths for infections caused by protozoans and worms respectively. So, when there is antimicrobial resistance, this means that your antimalarials no longer work. Your symptoms, which usually subside after a few days of taking your antibiotics, remain even after completing the dosage, and you may have to prolong the duration of usage or take another drug entirely. This leads me to the causes of antimicrobial resistance. The number one cause of AMR is drug abuse and misuse. Yes, using antimicrobials indiscriminately causes more harm than good. Honestly, I doubt if it does any good at all. I have an episode on drug abuse titled Drug Abuse Cycle, and I've taken time to explain it in details, so please do well to listen to that after this episode. Ideally, antimicrobials are not over-the-counter medications. That is, they shouldn't be dispensed without a valid prescription. In developed countries, you can't get your hands on antibiotics anyhow because they are more conscious of this antimicrobial resistance we're talking about. Unlike here in Nigeria, where a patient can just walk into the pharmacy and order antibiotics like sweets, you'll be hearing things like, "Give me 2 capsules of Ampiclox," or "I want 1 sachet of amoxicillin." If the pharmacist should go ahead and probe why they need the medication, they believe you're prying and it is none of your business. This is a wrong mindset because abuse of antimicrobials begins from getting incomplete doses, which means you're not planning to use it appropriately in the first place. This drug abuse also extends to animals, People who have poultry or rare livestock may also be giving these animals antibiotics indiscriminately instead of employing the services of a veterinarian. They mix antibiotics with their feeds and water and just give them anyhow, either they are sick or not. These organisms in these animals therefore develop antimicrobial resistance, and they are in turn passed to humans who consume them. Christmas is by the corner, A lot of people consume chicken, beef, and all of that. Who knows how many are actually taking in resistant microorganisms from these animals that have been given antimicrobials indiscriminately while rearing them. Some antimicrobials are also used as pesticides, so the resistance is also passed from plants to humans through consumption. Some are washed by rain into water bodies, which are also taken by humans. Another cause of AMR is overprescription. This is the fault of healthcare providers anyway. Some of the fault could also lie with the patient because normally, before prescribing any medications, a diagnosis has to be made. And to make a diagnosis, you have to run appropriate tests. Of course, when it comes to antimicrobials, empirical treatments are allowed only as placeholders till the result of your microbial culture sensitivity or any test to detect the microorganisms is out. Then you can switch to the appropriate antimicrobial for your infection. But like I said, the ideal is not the case most times. We do more of symptomatic treatment, which result to a kind of guesswork because many a times the patients are not willing to run tests. They would say that they prefer to use the money they would have used to run the test to get the medications. But it doesn't work that way. That money you are using to run tests is to ensure precision. And this may save you a lot of money that could have been wasted doing trial and error. So, back to the overprescription matter. Because your healthcare providers do not have a guide to help them identify the organism and the best medication for treatment, they tend to overprescribe in a bid to cover as many microorganisms as possible because they don't know which one they are up against. Environmental pollution from waste and chemicals released by pharmaceutical and manufacturing industries is another major cause of AMR, as well as inappropriate disposal of expired medicines by individuals, clinics, and hospitals. All this lead to the evolution of microorganisms and results to the emergence of what we call superbugs. These are multi-drug resistant organisms that cannot be eliminated with many antimicrobials. This has made it difficult to treat diseases like malaria, tuberculosis, and HIV. This leads me to the effects, or should I say dangers, of antimicrobial resistance. The first one is increased morbidity, that is, prolonged infections, which in turn leads to increased spread of diseases, more financial burden on the populace who are trying many medications to treat a certain infection, and eventual death when all are failed. No one wants this, really. Do you know how painful it will be when common infections that used to be treated with simple antimicrobials become untreatable, even after deploying the strongest antimicrobial available due to resistance? Let's not get to that point, please. It is very dangerous. The death toll will be unimaginable. That is why AMR is called the silent pandemic. Majority seem not to be paying attention to it. Many people are not even aware of it, but it is spreading so rapidly. In 2019 alone, over 1.2 million people died globally due to bacterial AMR, not to talk of other forms of AMR. And WHO has predicted a death toll of 350 million by 2050, rising up to an estimated yearly death of 10 million. Imagine that. We don't want that, do we? The thing with AMR is that these superbugs can be spread so easily in a population. You don't have to be directly involved in abuse of antimicrobials. As long as the resistant organism is in your environment, you are in danger of having it as well. I told you these organisms are everywhere in our environment. So really, there's no escaping them. It is better to prevent having them because really, in the nearest future, there may be truly no cure. Although science is doing its best to come up with newer antimicrobials and scientists are working day in, day out, the rate at which new antimicrobials are being discovered is slow compared to the earlier days. And the downside is that majority of these are not newly discovered. Rather, they are developed from tweaking already existing antimicrobials. So the resistance to them can develop anytime. Now, scientists are trying to see how they can circumvent resistant microorganisms, but there's still a long way to go. Instead of being reactive, why can't we prevent these things? Let me briefly talk about the mechanisms of resistance so that you can understand my last statement better before finally talking about the way out. Like I always say, Darwin's theory of evolution still holds true today. Remember survival of the fittest from biology? Yes, every organism is just trying to survive. Bring a challenge, they find ways to overcome it. Introduce a new drug, they find a way to grow despite it, and even overpower it. It is truly a battle of strategy, and microorganisms are arguably as intelligent as humans. Some of the ways they ensure survival despite efforts to kill or inhibit them, which we call the mechanism of resistance, are: 1. Some microorganisms inactivate the drug by modifying its structure. 2. Some find a way to reduce accumulation of the drug, thereby rendering it ineffective. 3. Some also resist by dodging or circumventing some essential pathways through which the drug can inactivate them. 4. There are some microorganisms that also increase their multiplication or production of certain target enzymes in response to the presence of my medications, thereby overpowering the medications. And finally, some microorganisms change specific drug targets in their structure or specific enzymes that the drug can recognize to inactivate them. It's like they are chameleons, changing so that they are not recognized by the drug anymore. Let me stop there and not go so much into the chemistry of it. I hope that this is simple enough to understand though. So, I have talked a lot about AMR and all the bad things it could do. Now let's talk about the silver lining, that is, ways in which we can prevent it and stop it in its tracks before it spreads even further. We don't want that WHO prediction to come to pass now, do we? The very first prevention strategy is not to abuse or misuse antimicrobials. How can you do this? 1. Avoid self-medication. See your healthcare provider for all your health complaints. Qualified ones, because there are quacks everywhere. So you have to be careful who and where you go to. Use your medications responsibly. Finish your medications. Follow instructions to the letter. If anything is unclear about your medication dosage, ask questions. Also, do not share your medications. Lastly, avoid indiscriminate use of antimicrobials in animals and as pesticides. Ensure proper disposal of medicines. I'll be doing an episode on that very soon, so watch out for it. And to my fellow healthcare providers, antimicrobial stewardship is what we can do to combat antimicrobial resistance. Let us try as much as possible to make decisions based on laboratory tests and not trial and error or symptoms. We can convince the patients and make them see the need to run these tests. After all, it's for their benefits. Let us also educate our patients and members of the public about AMR, like I'm doing right now. More importantly, let us practice AWARE, as recommended by WHO, which is actually an acronym for the appropriate use of antimicrobial. A stands for access. Those are access antibiotics that have a narrow spectrum of activity and a good safety profile in terms of side effects. Examples are penicillin, some cephalosporins, metronidazole, chloramphenicol, sulfur drugs. WA is for watch. These are antibiotics that are broader spectrum antibiotics and are recommended as first choice options for patients with the more severe clinical presentations or for infections where the causative pathogens are more likely to be resistant to access antibiotics. Examples are some cephalosporins, vancomycin, fluoroquinolones, and aminoglycosides. RE represents reserve, which is used to classify reserve antibiotics that are last choice antibiotics used to treat multi-drug resistant infections. Examples are the likes of carbapenems, colistin, linezolid, and newer generation cephalosporins. Don't worry about these classes I'm mentioning. Your healthcare provider knows what to give you, okay? You should get your antibiotics after you've seen your healthcare provider. Healthcare providers can get their hands on the WHO list of specific medications in these categories to guide them. Researches are still ongoing to combat antimicrobial resistance, so the fight is still on. Shout out to the researchers and all those working in the public health space to combat this menace. Shout out to me as well, okay? May the best organism win. In this case, I hope it is we humans. And that's a wrap on today's episode. Share with everybody in your circle. Let them listen and be aware. Remember, AWARE. Also, do not forget to like, subscribe, follow, comment, and engage me on any social media platform of your choice. I'm on Instagram as Aunty Pharmacist Podcast, on LinkedIn as Bemisola Adebisi Jose, on Facebook as Bemisola Adebisi Jose, on X as pharmpodcaster. You can also reach me via mail at antipharmacistpodcast@gmail.com. For those who used to listen via Google Podcast, it has now been changed to YouTube Music, so listen from there as well. Thank you so much for your continuous support. Till next time, stay healthy and God bless you.